Hello guys, in this video we're going to discuss Armstrong number and Armstrong number in a given range. If you are new to the channel, these are the entire topics that we're going to discuss in this playlist. Most commonly asked coding questions, and we're going to discuss from basics to advanced level and in the three languages C, Python and Java. And we are at getting started problem number 7, that is Armstrong number. Yeah, most of the people might confuse about Armstrong number, whether a given number is Armstrong or not. Let's take an example. Let's take 153. To check whether the number 153 is an Armstrong number or not. To know that, first you need to know what's an Armstrong number, right? So if a number, let's take 153 is an Armstrong number, if and only if each digit of the number, that is 153, raised to the power of the order of the number. So what's the order of the number? Order means number of digits in that number. In 153, how many number of digits are there? Three digits, right? So each digit raised to the order of the number, that is 1 cube, 5 cube and 3 cube. If we add this all, if we get the same number, which is 153, then the number is an Armstrong number. So this you need to understand. Not cubing the number. I have seen many websites that are showing each digit cube of the number sum is equal to the number, then the given number is an Armstrong number. No, that's not a correct definition. Let's take another example, 1, 2, 3, 4. So what's the order of the number here? Number of digits 4. In this case, 1 power 4 plus 2 power 4 plus 3 power 4 plus 4 power 4. If this sum equal to 1, 2, 3, 4, then this is an Armstrong number. So you need to know this difference, not cube of the each digit raised to the power of the order, that you need to know. So now you understand the definition of an Armstrong number. So let's take an example and I will explain it. Let's take a number, example 9474. Yeah. So first, for a given number, you need to find the order, right? So what's the order? Order is 4. So how to get the order 4 from this number? So it's an easy method. I have told in the previous examples also. Whenever if we divide a number by 10, you will get the entire number except the last digit. And if we do percentile the number, you will get last digit. So you need to understand this. So 9474. So the number which is divided by 10. So 947 times 9470 and 4 is the remainder. And next what we should do, we should continue with 947. Same applying division, 947, 94 times 947 is the remainder, and same continue, 94, 9 times 90 and 4 is the remainder, and after that same continue, 9, 0, 0 and 9 is the remainder. Whenever the quotient becomes 0, then stop. If you observe carefully, whenever I am doing this division operation, if 10 is doing division, then I am getting the entire number except the last digit, 947, right? And by doing percentile operation, I am getting the last digit, right? So here also same, by continue 947, here the 947 came here, and same by doing division operation, I got the entire number except the last digit, here 94, and to obtain the last digit, I am doing percentile operator 7, and I am doing this entire procedure until this part becomes 0 and stop, right? So how to do coding in this? I have explained in this previous example also. So if you observe carefully, to obtain the order, we will be taking a variable called length initialized to 0, and after that I am taking the number in a variable n is equal to 9474, and after that running a while loop. While, what's the condition I have explained before also? While n is not equal to 0, and in the loop I am incrementing the length is equal to length plus 1, and after that I am doing division operation to obtain the entire digit except the last one. So n is equal to n by 10. Yeah, this loop executes, and after that it will give the order. The order means the length of the number. How many digits are there in the number? That is exactly 4. Are you getting? First here n is equal to 1, 2, 3, 4, and n is equal to 1, 2, 3, 4, and n is not equal to 0, right? So it will go into inner loop, and after that length is incremented. Now first length is equal to 0, then length will be 1, and after that n is equal to n by 10. So n will be 947 only, and after that 947 is not equal to 0, again length is incremented, so length is equal to 2 now, and same n is updated, n is 94 now. 94 is not equal to 0, the same length is 3, and 94 is converted into 9, same 9 is not equal to 0, and after that length is equal to length plus 1, so length is equal to 4 now, and n is incremented to 0. Here n equal to 0, this loop is exited, and after that length is opted. What's the length value? 4. That's an order. Like that we will be calculating the order of the number, and after that what we should do? A number is an Armstrong number, like A, B, C, D and so on. N is an Armstrong number if and only if A power n plus B power n plus C power n plus so on n power n, that must be equal to A, B, C, D and so on n. So this we need to understand first, and first we have find the order which is n, and after that we need to do this power operation and addition operation. The number is 9474. Now we got an order, right? So order is 4. Now we need to extract the digits and multiply each digit 4 times, and after that add. So how to code this? First we need to extract each and every digit, right? So how to extract 4 from 9474? By doing percentile operator. And the same thing here. First, while n not equal to 0, what I am doing, I am extracting a digit equal to, how to extract it? N percentile 10. By doing this I will be getting 4 in the digit place, right? And I am taking a sum variable, sum equal to, first I am initializing sum to 0, and after that sum is equal to, what should I do? I got a digit, I have to multiply the digit order number of times, or I have to raise the digit order number of times and add it. So what's this? What would be the sum value? Sum is equal to sum plus digit power what? Order. So I am doing sum is equal to sum plus digit power order, and after that I have to update the number, right? n is equal to n by 10. Yeah. If you observe carefully, every loop, the n value is updated. So to track the n value, I am taking another variable which is temp, and I am storing the value n here. So after that, I can check whether if n is equal to temp, then it is obviously an Armstrong number, else not Armstrong number. So this you need to understand. What I have done here, first I am taking a while loop, and after that I am extracting each and every digit, right? For extracting digit I am using percentile operator, and after that I am taking another variable sum, and in that sum I am adding sum plus each digit power order. This you need to understand. To perform this operation, each programming language has different syntax. In C language, you might use POW function, POW of digit comma how much order, and in Python you can directly write double star. Java we can use math.pow and digit comma order. And if you are not allowed to use any predefined functions, then you directly use a while loop or a for loop and iterate to order number of times and multiply the digit. So anything is okay, right? And after that, updating the number to n by 10 so that the n is updated, and each time I am getting the last digit, and after that the sum has our desired format, like each digit power order is added, and after that we will be checking whether the n is equal to here, not n is checked, here sum is checked. Yeah, whether sum is equal to temp, then it is obviously Armstrong number. If it is not correct, then it is not an Armstrong number. So let's do coding. Yeah, first I need a number which is int num is equal to, let's take a number 1634, 4-digit number, and after that first we need to find the order of the number. So I am writing a function int order. This function will take a number, that is int. Yeah, what this function will doing? This function is calculating the number of digits in the given number and returning it. That's it. So first I need to take a length variable and initialize to 0, and after that I am taking while loop. And what's the condition I have tell before also? X not equal to 0. This number not equal to 0, and I am doing division operation, right? So first I will update the length, and after that update the number x equal to x by 10. So what this loop will be doing, every time the length is incremented and the x is division by 10, so that the entire digits except the last digit is updated. So after executing this entire while loop, the length variable consists of the length of the number. So return it, return len, that's it. And after that, yeah, and in this order function is completed. And now in the main function, num consists of 1 2 3 4 variable, and I need to get the number of digits num variable has. So that I have written order function. I will call it int length is equal to, I will call the function order of, I will pass this num. Yeah, now I have a number and I have the length of the number. So now I need to write a code for Armstrong number. So I am writing another program, another function int Armstrong number, and this number takes two arguments, that is first an integer num, and after that the order, that is length, right. I recommend you to do coding using functions so that the code is reusable. And the Armstrong number, first I will be having a sum variable which consists of the sum and initialized to 0, and after that I am taking a temp variable so that the updated num value is stored before, and I am initializing it to num, that is int temp, and after that I should manage, okay, at each and every iteration I need to get the digit right, so I am initializing an integer digit, yeah, and after that while loop, while, so what's the condition, num not equal to 0, and I am applying modulus operation. By applying modulus operation, I will be getting in the units place in every loop. So how to get the digit equal to num percentile 10. So I got the units place, and I should update the sum, right? Sum is equal to sum plus, yeah, here the digit power of the order. So in C language, what we will be doing, there is a function called POW, and it takes two arguments, that is the digit and the power. So what's the digit here? Digit is there in the digit variable and the power is there in the length variable. Yeah, what this will do, it will raise the digit to the power of len and adds to the sum. So this is what we want, no? And after that the num value is updated, num is equal to num by 10. Yeah, by doing this, first in each and every loop, first digit is extracted, that is units place, and after that for this sum the previous sum is added and the digit is raised to the power of length, and after that the num value is updated as num is equal to num by 10. So after executing this loop, what we will be doing, we will be checking a condition if the sum is double equal to the temp, that which is previously num, and if it is true then we should print an Armstrong number. If it is false then we should return not an Armstrong number, right? By not writing if and else case, we can do directly also. We can directly return temp double equal to sum. So what this will do, if it is true then it will return 1, if it is false then it will return 0. So that's very simple. Instead of writing if and else, we can directly write a expression which evaluates, and that number will be given to the function, main function. So in this main function, if I'm calling Armstrong number function, Armstrong of, so what's the number num and what's the order len. So if this is true, then what should I print? Printf percentile d is Armstrong number. And what's the percentile d? That is num, right? So after that, if this is false, that then else case is executed, and in this else case I should print percentage d is not an Armstrong number. That's it. So let's run the code. Yeah, as you can see, 1634 is an Armstrong number. Let's take another number. Example 163. Save the code and run. Yeah, 163 is not an Armstrong number. So this is very easy. And when it's come to time and space complexity, for space complexity, we haven't used any extra space. So obviously the space complexity is big of 1. Yeah, when it comes to time complexity. So what functions we have written? First, the order function. What order function will do? It will iterate and tell how many digits are there in the number. So this entire order function's time complexity is big of d. That means it will iterate up to d number of times. D means digits, no? So obviously the time complexity here, first big of d, right? And after that there is another function here, Armstrong, int Armstrong, and in this case also, how many times this while loop will be iterated? Obviously that how many digits are there, that many times the while loop is iterated. So for this while loop, the time complexity is big of d, and after that for performing this power operation, the time complexity is log d. So these two are performing in the same loop, so we need to multiply them, right? So the time complexity will be big of d plus d into log d. Are you getting? First, for this order function, the time complexity big of d, and after that for Armstrong function, the time complexity is big of d into log d. This for this while loop, that is big of d into log d. For this while loop, how many times this while loop is iterated? D times, and every time the power function is called. For power function, the time complexity is log d. So what's the time complexity of this while loop then? We should multiply d and log d, that is d into log d. That's it. So the time complexity is big of d plus d into log d. This is equivalent to big of d into log d. So that's very easy. And I have prepared the solution document also. I will explain Python and Java coding. First Python. Here also the same thing, but the syntax changes. Here I am taking a num which is 1634, and after that length. For to get the order, I have written order function, diff order, and here I can use directly len function, or I can also use in operator and iterate to the loop and increment the length operator and increment the length variable and return it. So anything is okay. And after that for Armstrong also, I am taking temp variable and storing the num sum is equal to 0, while temp is greater than 0. You can use anything, temp greater than 0 or temp not equal to 0, and digit is equal to digit percentile 10. I am extracting the digit and I am updating the sum value. Sum plus equal to digit star star length. So this star star, what this star star operator will do? The star star operator will multiply the digit into how many number of times, that is length number of times. That's it. And after that I am updating the temp is equal to temp by 10 and return sum is double equal to num. The same thing will be happen. If is Armstrong and calling the function is Armstrong, and I am giving two variables, that is first the number and after that order length of the number. If it is true, then obviously I will be printing the number is an Armstrong number, else it is not an Armstrong number. And the same, the time complexity also same. For this order, the time complexity is big of d, and if for this Armstrong, d into log d. So what's the majority of this? D into log d. So that's the time complexity. And for Java also the same thing. For order function, int length is equal to 0, while num is not equal to 0, length plus plus, and I am updating length divided by 10. Updating length is equal to length by 10, and I have written the length. And the same Armstrong also, int sum is equal to 0. Temp, I am storing the num in temp, and digit, each and every time digit is equal to temp percentile 10. And here for power operator we will be using math dot power of digit comma length, and after that in the main function also n is equal to 1634, an order. To get an order, calling order function, and after that if is Armstrong of num comma len, I am printing the given number is Armstrong number or not, and else not. So that's very easy. If you first learn in C language, then it's very easy in Python and Java also. That's why I recommend you to learn in C language. Next, Armstrong number in a given range. So if you solved the Armstrong number, then you completely solve the Armstrong number is given range also. You need to just add a for loop in the main function so that to get the output, right? So you solved Armstrong number, right? So what's the next one? Eighth question. So what's the eighth question? Armstrong number in given range. Yeah. So we have Armstrong number code here and order code here, right? Previously for a number n, the Armstrong number is calculated. So now the slight change is the n is varied. That's it. For low to high, there are so many number of numbers, and each number is called to the Armstrong number function and tell whether the given number is Armstrong number or not. So that's very easy. Let's solve it. This is the code for Armstrong number, right? Here I am using a single number 163. So yeah, I am taking a range here. So int low is equal to 200, int high is equal to, let's take 1000. So what I am doing in the range from low to high, I should tell whether the how many numbers are Armstrong numbers and print them. So that's it, simple. Yeah. For that I am taking a for loop which runs from low to high, right? Int num is equal to low and num less than or equal to high and num plus plus. So what this for loop will do, it will take from starting 200, 201, 202, 203 and so on up to 1000. And for each and every number, we will be checking whether the number is Armstrong number or not. Simple. So first we need to get the order, right? So first int len is equal to order function, order of num, and after that I will be calling Armstrong function. Simple. If Armstrong of what's the number num, comma what's the order length. If this is true, then what we should print? Printf percentile d is Armstrong. Sorry, we will just printing the number percentile d and the number is stored in num, right? Yeah. And after that, after printing the number, I am just keeping a tab space so that the other numbers also comes. And let's execute this code. Yeah. In the range of 200 to 1000, 370, 371 and 407 are the Armstrong numbers. Here this is the code for C language and for Python and Java also. Yeah. For Python and Java also the same thing. Just take two variables, low is equal to 200, high is equal to 500. for num in range of low comma high plus 1, calling the order function and checking each and every number is an Armstrong number or not and printing it. Simple. And the same thing in the Java also. Taking into low is equal to 200, high is equal to 500, num is initializing num to low and ranging to high and updating the num and getting calling the order function and the same thing. So what's the time complexity here? So to get the time complexity, so first I have said before, for order calculation, big of D, where D is the where D is the number of digits in the number, right? For Armstrong number check, what's the time complexity? D into log D for each number. And after that, the extra case, that is a for loop added here, this for loop. And for how many times this for loop will executed? Obviously high minus low plus 1. So let's take n as high minus low plus 1. So this for loop will execute n number of times. So at that time, what's the time complexity? N into D into log D. So for this Armstrong check, so I previously discussed, for just Armstrong number, the time complexity is big of D into log D, and this entire code is placed in a for loop, right? Here, the entire code is placed in a for loop. So n is multiplied to the time complexity, so that the time complexity, overall time complexity is big of n into D into log D, where n is the range size from starting low to high and D is the average number of digits. That's it. Yeah. If you really like my videos, do subscribe, like and share and give some feedback also.